Hello, welcome to my class. In this video, we are going to discuss exercise 1.3 from the chapter number system. And if you have not subscribed to my channel, please subscribe and do like the video if you like my class and share it with your friends. Do not forget to click the bell icon to get notifications also. If you have any doubts, you can ask that as comments. Okay, so let us start now. And the first question is, write the following in decimal form and say what kind of decimal expansion each has. And the first one, in first question, first subpart is 36 by 100. We have to say what kind of decimal expansion it has. After writing it in decimal form, we have to say what kind of decimal expansion it has. So, dividing 36 by 100, what will you get? 0.36. And what kind of decimal expansion it has? It has terminating. That is, it will terminating. That is, it is terminating after 6. So, it has terminating decimal expansion. Next one is 1 by 11. We can do long division to find this. 1 divided by 11. And we'll get 0 then 10. In 10, 11 will go 0 times. Then in 100, 11 will go 9 times. So we'll get 99. 9 into 11 is 99. Then 1 remainder. Now if you put 0, in 10 you will get 0. That is 11 will go 0 times. Then in 100, 11 will go 9 times. 99. Then 10 again. So 0. And in 100 it will go 9 times. 99. 1 remainder, etc. So you will get the quotient as 0.090909, etc. Which means it is 0.09. We can write like this. That is 09 is repeating. So this is a non-terminating repeating decimal. Right? This is of the form non-terminating repeating decimal. Okay. Now third one is 4 1 by 8. To convert 4 1 by 8 to decimal form, it is 4 and a fraction, right? 4 and 1 by 8. So we will get it like 4 point something. And for that, divide 1 by 8. Find 1 by 8. So divide 1 by 8 by the long division process. We will get 0 point, and if we take 0, 10 by 8 is 1. Then 8, 2 remainder. Now 20 by 8 is 2. 16. 2 into 8 is 16. So 4 remainder. 20 minus 16 is 4. Then in 40, 8 will go 5 times. And 40, 0. So this is 4.125. Which means this is terminating decimal. That is, it is terminating after 5. So, this is a terminating decimal. Now, 3 by 13. So, we can do this. 3 divided by 13 and 0 point. In 30, 13 will go 2 times and it is 26. 2 into 13 is 26. And 30 minus 26 is 4. Then in 40, 13 will go 3 times. And 3 into 13 is 39. Then 1 remainder. And in 10, 13 will go 0 times. Then add a 0 here. In 100, 13 will go 13 into 6 is 78. 13 into 7 is 91. So 13 will go 7 times and 91. We have 9 remainder. So 90. In 90, 13 will go. 13 into 6 is 78. So 6, 78 and 12. And in 120, 13 will go 9 times. 117. So it will go 9 times and 117. Now 30. In 30, 13 will go 2 times. So we have 2 into 13 is 26. Then in 40, 13 will go 3 times. And we'll get this as 39. Then 1 remainder. In 10 it will go 0 times. So it will repeat. 230769 will repeat. So we can write this as 0.230769. It is 0.230769 which is repeating. So this is a non-terminating repeating decimal. That is, these numbers will repeat again and again. This part 230769. This will be 0.230769, 230769, 230769, etc. That is, this part will repeat. So it is a non-terminating repeating decimal. Now 2 by 11. 2 by 11. So we can do long division and 0 point. In 2011 will go 1 time and 9 is the remainder. And in 9011 will go 8 times, 2 is the remainder. In 2011 will go 1 time, then 9 is the remainder. In 9011 will go 8 times, then 2 is the remainder, and it will repeat. So this 18 will repeat again and again. So we can write this as 0.18, which means this 18 is repeating. So this is a non-terminating repeating decimal. Non-terminating repeating decimal, or we can write recurring. And here this is non-terminating recurring decimal, and this is terminating, and this is non-terminating recurring or repeating, and this is terminating. Okay, so a rational number is either terminating or non-terminating repeating. A decimal which is non-terminating and non-repeating, it will be an irrational number. Okay, so if the decimal is non-terminating and non-repeating, then it will be an irrational number. Okay, now next one is 329 by 400. 329 by 400. We can take this as 329 by 4 into 100. What is 329 by 100? It is 3.29. So we will get this as 3.29 by 4. Now we can divide this by 4. So 3.29 by 4. What is 3 by 4? It is 0. So write a 0 here. Now there is a point here. So we have to put point. That is decimal. Now take this 32. Now 32 by 4 is 8. And we can write 8 into 4 is 32. So 32 minus 32 is 0. Now bring this 9 down. Now 9 by 4 is 2. And 2 into 4 is 8. So 1 remainder. And we can write this as 0, 0, 0, 0, etc. So bring this 0 down. And 4 will go in 10 2 times. And 4 2s are 8. Then 2 remainder. Now bring this 0 down. Now 20 by 4 is 5. Then 5 into 4, 20. Then 0 remainder. So this has terminated after this 5. Which means this is a terminating decimal. 0.8225. This has terminated after this digit 5. Which means this is a terminating decimal. So 329 by 400 is 0.8225. Next one is, we know that the decimal expansion of 1 by 7 is 0.142857. This is repeating. So can you predict the value of 2 by 7, 4 by 7, 5 by 7 and 6 by 7? This is easy. Just multiply this by 2. That is 1 by 7 is this. So 2 by 7 will be 2 into 1 by 7. So multiply this by 2. 142,857 by 2 is 0.285714. This will repeat. Okay, now 4 by 7. So multiply this by 4. So we'll get 1, 4, 2, 8, 5, 7 into 4 is 7 fours are 28. 5 fours are 20. 20 plus 2 is 22. 4 eights are 32. 32 plus 2 is 34. 2 fours are 8. 8 plus 3 is 11. 4 fours are 16. 16 plus 1 is 17. And 1 into 4, 4. 4 plus 1 is 5. So we'll get this as 0.571428 and this will repeat. All these numbers will repeat. Now 5 by 7. Multiply this by 5. So we'll get 142,857 by 5. 7 fives are 35. 5 fives are 25 plus 3 is 28. 8 fives are 40 plus 2 is 42. 2 fives are 10 plus 4 is 14. 4 fives are 20 plus 1 is 21. Then 1 5 is 5 plus 2 is 7. So we have 0.714285 which will repeat. Now 6 by 7. So multiply this 142,857 by 6. 7 6 are 42. Then 5 6 are 30 plus 4 34. 6 8 are 48 plus 3 is 51. 2 6 are 12 plus 5 is 17. 4 6 are 24 plus 1 is 25. 1 into 6, 6 plus 2 is 8. So we have 0.857142 and this will repeat. And we have to find one more decimal expansion which we left to find. It is 3 by 7. What is 3 by 7? Just multiply this by 3. So we'll get 142,857 into 3. 7 3s are 21. Then 5 3s are 15 plus 2 17. 3 8s are 24 plus 1 is 25. 2 3s are 6 plus 2 is 8. 4 3s are 12 and 1 into 3 3 3 plus 1 4. So this is equal to 0.428571. So we can write 3 by 7 is equal to 0.428571 and this will repeat. 428571 will repeat. Now, third question is express the following numbers in the form P by Q where P and Q are integers and Q not equal to 0. So, the question is 0.6. That is, this is repeating. 6 is repeating. So, we have to take, first we have to take x equal to 0.6666 etc. That is, this 6 will repeat. Now, 10x can be taken as, that is, if we multiply this by 10, we have to multiply this also by 10. So, we will get 6, if we multiply this by 10, we will get this as 6.666 etc. And if we subtract this 10x minus x, we have to subtract this also. That is 6.666 etc. minus 0.666 etc. So, if we subtract this, what will we get? 6.666 etc. minus 0.666. Here everything will be 6 and here also everything will be 6. So, if we subtract this, we will get as 6. So, this is equal to 6. Which means 10x minus x is 9x. So, 9x is equal to 6. Which means what is x? X is equal to 6 by 9 and 3 is common in both these numerator and denominator. So, if we divide 6 by 3, we will get 2 and if we divide 9 by 3, we will get 3. So, x is equal to 2 by 3. So, we can write this as 2 by 3 in the form P by Q. So, this is equal to 2 by 3, 0.6. This 6 is repeating, is 2 by 3. Next one is 0.47. Write this in the form P by Q where P and Q are integers and Q not equal to 0. So, this can be written as, first we can write this as x is equal to 0.47. and that is equal to 0.4777 etc. This 7 will repeat. So it can be written as 0.477 etc. Now, since one digit is repeating, we have to multiply this by 10. So 10x is equal to, we have to multiply this by 10. So if we multiply this by 10, we will get 4.777 etc. And we can write this as 4.3 plus 0.4777 etc. Right? Because 4.3 plus 0.4777 etc. is 4.7777 etc. Right? So we can write this as 4.3 plus 0.477 etc. which is equal to 4.3 plus, this is nothing but x. So 4.3 plus x. Now take this x to the left hand side. We will get 10x minus x is equal to 4.3, which means 9x. What is 10x minus x? It is 9x. 9x is equal to 4.3. So x is equal to 4.3 by 9. Now to convert this to a number without decimal, we have to multiply this by 10. So if we multiply this by 10, we have to multiply the denominator also by 10. So if we multiply this by 10, we will get 43. 9 by 10, we will get 90. So 43 by 90 is 0.47. 7 repeating is 43 by 90. Next one is 0.001. This 001 is repeating. So we can write this as x is equal to 0.001. 001 is repeating. So we can write it as x equal to 0.001, etc. And since 3 digits are repeating, we can multiply this by 1000. So 1000x is equal to, if we multiply this by 1000, what will we get? It will be 1.001001 etc. Right? That is, if you are multiplying by 1000, we have to move this decimal 3 digits to the right. So we will get 1.001001 etc. Now this is equal to 1 plus 0.001001 etc. Right? And what is 0.001001 etc.? It is x. So we can write it as 1 plus x. Okay. Now bring this x to the left hand side. If we bring positive x to the left hand side, it will become negative x. So we will get 1000x minus x is equal to, what will remain here? We will have 1 here. So it is equal to 1, which means 1000x minus x is 999x. So 999x is equal to 1. So what is x? X is equal to 1 by, this is 999 into x. So if we take this to the right hand side, it will become divided by. So it is 1 by 999. So we can write 0.001 where 001 is repeating in the form 1 by 999. That is in the form p by q as 1 by 999. Understood? Now, next question is express 0.9999 etc. That is 9 is repeating in the form p by q. And are you surprised with your answer? That is the question. So, we will see how we are getting surprised. So, 0.9999. How will we change this to the form p by q? Take this as x. So, x is equal to 0.9999 etc. Okay. Now, since one digit is repeating, this can be written as 0.9. And here, one digit is repeating. So, we have to multiply this by 10. So, 10x is equal to, if we multiply this by 10, we have to multiply this also by 10. If we multiply this by 10, what will we get? This decimal will move one digit to the right. So, it will become 9.999 etc. And this is equal to 9 plus 0.9999 etc. Right? This is 9 plus 0.9999 etc. And what is 0.9999 etc.? It is x. So we can write this as 9 plus x. Now taking this plus x to the left hand side, it will become minus x. So 10x minus x is equal to 9. Which means 9x is equal to 9. So what is x? X is equal to 9 by 9, which is equal to 1. And why we are getting 1? That is the question. Are you surprised with your answer? Yes. We have 0.9999 etc. and we are getting it as 1. Why are we getting it as 1? Because 0.9999 etc. What is it? It is nearing to 1, right? That is, if we draw number line and we have 0 to 1 here, and this, let us say this is 0.9 and 0.999 etc. As it is going like this, 0.9999 etc. It is nearing to 1, right? So we can approximate it to 1. And what we are getting here is this answer, that is, it is 1. Okay. Next one is, what is the maximum number of digits in the repeating block of digits in the decimal expansion of 1 by 17? 1 by 17. So, what can be the maximum number of digits in the repeating block of digits? So, it can be 17 minus 1. Maximum number of digits which are repeating can be 17 minus 1, which is 16. Okay. Now, we will perform division to check whether our answer is correct. So we can write it as 1.00000000000 and we can divide this by 17. And will 17 go in 1? No. So write a 0. Then decimal. Now will 17 go in 10? No. So write a 0. Then will 17 go in 100? Yes. 17 will go in 100. 17 into 5 is 85. So 17 will go in 100 5 times. So we'll get 85 and what is the remainder? It is 15. Now bring this 0 down and 17 will go in 150. 17 into 8 is 136. So 136 and what is the remainder? 14. Now bring this 0 down and 17 will go in 148 times itself because it is 136. So 8 times 136. Now what is the remainder? 4. Now bring this 0 down and 40 by 17 is 17 into 3 is 51. So 17 into 2 is 34. So 2 and 34. Now remainder is 6. So 60. 60 divided by 17 is 3. 17 into 3 is 51. And remainder is 9. Now bring 0 down. Then 90 by 17 is 5 itself. Because 17 into 5 is 85. So 5, 85, then 50. And 17 will go in 50 2 times because 17 into 2 is 34 and 17 into 3 is 51. So 34 and remainder is 16 and we'll get 160 if we bring 0 down. And 17 into 9, 7 nines are 63, 153. So 17, so it will go 9 times and we have 153. I'll write here and 160 minus 153 is 7. So bring 0 down and 70. Now 17 into 4. 17 into 5 is 85. So 17 into 4. 7 4s are 28. So we'll get 68. So 4. 68 and 2 remainder 20. 17 will go 1 time and remainder is 3. Now 30. In 30, 17 will go one time. So 17. Now 13 remainder and bring 0 down. In 130, 17 will go. 17 into 8 is 136. So 17 into 7. What is 17 into 7? 7 sevens are 49 and 119. So it will go 7 times. 119. Remainder is 11. Now bring 0 down. And in 110, 17 will go 6 times. And 17 into 6 is 42. Then 4 plus 6 is 10. 102. So 102 and remainder is 8. Now in 80, 17 will go 4 times because 17 into 4 is 68 and remainder is 12. So 4 times and remainder and we'll get 68. Remainder is 12. Now bring 0 down and in 120, 17 will go how many times? 7 times because 17 into 7 is 119. So 119 then 1 remainder and bring 0 down and in 10 how many times it will go? 0 times. Now bring 0 down and in 100 how many times it will go? We have 17 into 5 is 85. So 5 times. So 85 and 15 remainder. Now in 150 it will go how many times? 8 times. So 8 and we'll get 136. 8 into 17 is 136. 14 remainder. Now bring 0 down and in 140 it will go 8 times. So we'll get 136 again. So it will repeat this 0, 5, 8, 8, 2, 3. So from till here this is the repeating block and after this it will repeat again and again. It will be 0, 5, 8, 8, 2, 3, 5, 2, 9, 4, 1, 1, 7, 6, 4, 7. This will repeat. That is these 16 digits will repeat after this process. So we'll get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So if a rational number is 1 by n, it can have maximum n minus 1 digits in the repeating block. Now, sixth question is, look at several examples of rational numbers in the form p by q where p and q are integers with no common factors other than 1 and having terminating decimal representations. Can you guess what property q must satisfy? So, let us say the rational number is 1 by 7. And what is 1 by 7? We'll get it as 1 by 7. We'll get it as 0 point. Then 10 by 7 is 1. Then 3 remainder. Now 30 by 7 is 7 fours are 28. Then 2 remainder. Now 20 by 7 is 2. 7 twos are 14. Now 6 remainder. Now 7 eights are 56 and 4 remainder. Now 7 fives are 35 and 5 remainder. 7 sevens are 49. 1 remainder. Now in 10, 7 will go 1 time. Then 3 remainder. In 30, 7 will go 4 times. So this will repeat. 1, 4, 2, 8, 5, 7 will repeat. So this 1 by 7 is of the form non-terminating repeating decimal form. And if we take 1 by 2, 1 by 2 is nothing but 0 0.5. It is terminating decimal. And if we take 1 by 3, 1 by 3 we will get 0 0.3333 etc. It is non-terminating repeating decimal. That is, it is 0 0.3. 1 by 3 is 0 0.3. And what is 1 by 6? 1 by 6 is 0 point. Then in 10, 6 will go 1 time. 4 remainder. Now 40 by 6. 6 6 are 36. So 4 remainder. Then 6 6 are 36. 4 remainder. So this will repeat. 0.1666 etc. will repeat. So what type of decimal expansion it is? It is non-terminating repeating decimal. So this is non-terminating repeating decimal. Now if we take 1 by 5, it is in 1 5 will go 0 times, and in 10 5 will go 2 times. So we have 0.2. So it is terminating decimal. And if we take 1 by 10, what is it? It is 0.1. It is terminating decimal. And here when the denominator is 7, 3 and 6, it is non-terminating repeating. When the denominator is 2, 5 and 10, it is terminating. So what does that mean? If the denominator is a power of 2, that is, it is of the form 2 raised to n, or 5 raised to n, or a product of both, that is 2 raised to n into 5 raised to n, then it will be terminating. Okay, so that is why this is not terminating. The denominator is a power of 2 or a power of 5 or a power of both, then it will be terminating. Otherwise, it will be non-terminating repeating. Understood? So, for a rational number to have terminating decimal expansion, Q must be either a power of 2 or a power of 5 or a power of both. Now, next question is, write 3 numbers whose decimal expansions are non-terminating, non-recurring, which means it will be an irrational number. So, it can be 0.05, 005, 0005, 00005, etc. Then it can be 0.023, 1, 2, 3, 4, 3, 5, 7, 1, etc. And 0.173522368196357023, etc. So these are all examples of numbers which have non-terminating, non-recurring decimal expansion. Okay, now find 3 different irrational numbers between the rational numbers 5 by 7 and 9 by 11. Between 5 by 7 and 9 by 11, we have to find 3 different irrational numbers, 5 by 7 and 9 by 11. So we will find the decimal expansion of 5 by 7 first. 5 by 7, we can write it as 5.0000 divided by 7. Now 5 by 7 is 0 and here point is there. So 0 point, and in 57 will go 7 times. 7 sevens are 49 and 1 remainder. Now bring this 0 down. In 10 7 will go 1 time. So 7, then 3 remainder. Now bring the 0 down. In 37 will go 4 times and 7 4s are 28, 2 remainder. Now in 27 will go 2 times and 7 2s are 14, 6 remainder. Now in 67 will go 8 times, 8 sevens are 56. So 8 and 56, 4 remainder. Now in 47 will go 5 times, 7 5s are 35, then 5 remainder. In 57 will go 7 times, then 49, 1 remainder, and in 10 7 will go 1 time. So this will repeat, 7 1 4 2 8 5 will repeat. So 5 by 7 is 0.714285, which will repeat. And what is 9 by 11? So we can find it out. 9 by 11. So 9.00000 by 11. And 11 will go in 90 times. Then put a decimal. In 90, 11 will go 8 times. So 8 11s are 88. And 2 is the remainder. Now in 20, 11 will go 1 time and 11. So we have 9 remainder. And in 90, 11 will go 8 times. Then 88, 2 remainder. In 2011 will go 1 time, 9 remainder, and in 9011 will go 8 times. So 9 by 11 is 0.81. That is, this 81 is repeating. 81 will repeat. This is the repeating block. 81 is the repeating block. So we have to find irrational numbers between these numbers, that is, which are non-terminating, non-recurring. So we can find irrational numbers between this. So we can write it as 0.80, then 800, 80000. This is an irrational number because, and it will not terminate. Now we can write 0.75, 755, 7551, 7552, 7553, etc. And it will not terminate. Now we can have 0. It should be between 0.7 and 0.8, between this and this. So this is between this, and this is also in between this. Now we can have 0.7961, 7962, 7963, 7964, etc. This is also an irrational number between 5 by 7 and 9 by 11. So we have got 3 irrational numbers which are between 5 by 7 and 9 by 11. Now, ninth one, which is the last one. Classify the following numbers as rational or irrational. Root of 23. Root of 23 is an irrational number because this is not a perfect square. 23 is not a perfect square, and root of a number which is not a perfect square is an irrational number. So first one is irrational. Now root of 225. Root of 225 is nothing but root of 15 into 15. That is root of 15 square, which is 15. So 15 can be expressed as 15 by 1 or 30 by 2, etc. So it is a rational number. Any number which can be expressed as p by q, where p and q are integers and q not equal to 0, is called a rational number. Now third one, 0.3796. It is terminating. We don't have any digits after this. After 6 we don't have any numbers, which means this is a terminating decimal. And a terminating decimal expansion, a number having terminating decimal expansion, is a rational number. So it is rational. Rational numbers can have either terminating decimal expansion or non-terminating recurring. That is, if it is non-terminating, if it does not terminate, if the decimal expansion does not terminate, then it will be repeating. That is, look at this example, 478, 478. This will repeat. So in that case, it is a rational number. Otherwise, it is an irrational number. Consider this. This is an irrational number because it is not repeating. That is 0, 1. Now 0, 1 is not repeating. It is 0, 0, 1. So this is an irrational number, which means this is a rational number because all the terminating decimal expansions, all the numbers having terminating decimal expansions are rational, and all the numbers having non-terminating recurring or repeating are rational. All the numbers having non-terminating, and if it is non-terminating, it is recurring. And if it is non-terminating, it is not recurring, means it will be irrational. So this is irrational and this is rational. So this is rational, this is rational, and this is irrational. Fourth is rational and fifth is irrational. So we have completed exercise 1.3 from the chapter number system, and and we'll continue with exercise 1.4 in the next video. So if you have not subscribed to my channel, please subscribe and do like the video if you like my class and share it with your friends. Do not forget to click the bell icon to get notifications also. If you have any doubts, you can ask that as comments. Okay, thank you and bye.